Welcome back to another video on my channel, math_exe. Today we're going to talk about some example questions of linear function and graphs. But first I want to talk about some special equations of horizontal and vertical lines. So the equation of a horizontal line is in the form of y equals a, where a is wherever this line intersects the y-axis. So assume you have the equation y equals 5. It should look a bit like this. So you have the y-intercept at the coordinates of 0, 5. In the other hand, the equation of a vertical line is in the form of x equals b, where b is wherever the line intersects the the x-axis. So yeah. So assume we have an equation x equals, let's say, 3. Then this line will intersect the x-axis at coordinates 3, 0. I should have written that right here. Something like this. So this is all I have to say about some special equations of horizontal and vertical lines. So let's jump into some examples. Alright, for the first question. So usually in some linear functions and graphs type questions, there are like several parts that you need to answer, such as this one. So first you need to fill the following table for the values of the function 2x minus y minus 5 equals 1. So first what I would like to do is to express the function into like something nice, into like a point slope formula. So we know right here, I'll just write this. So x minus y minus 5 equals 1. Yep. And perhaps we can add by 2x plus 5 on both sides to get rid of this. And I should have said negative 2x minus 5 because we're going to rid of the positive 2x. So 2x will cancel with negative 2x. 5 will cancel with negative 5. And we have negative y is equal to negative 2 plus 5 plus 1, which is just negative 2 plus 6. And keep in mind we have a negative sign, so this equation changes into y equals 2x minus 6. So if you expand the negative sign, you get this expression. So we're going to use this to our advantage. So we're going to write this right here on the side. Okay, so when x equals negative 1, we can just substitute that in. So we have 2 times negative 1, which is just negative 2, minus 6, which is just negative 8. So this will be negative 8. And at 0 is 2 times 0 minus 6, which is just negative 6. So for 1, it will be 2 times 1 minus 6, which is just negative 4. And perhaps you can just fill the rest of this table, or you can just like test some inputs of x. However, I'm just going to write this right here. So it will look something like this. So we're done with the part A. Part B, we need to draw the function, and then we need to label the x and y intercepts. So we can just plot these coordinates on the xy plane, like so. So first, let's say x equals negative 1 is right here, and we have our y value at negative 8, which is way down right here somewhere. So our point should be right here. And then we have our y-intercept is at negative 6, and then we should probably label that. So There we go. And then we have 1 comma negative 4 for next point. Negative 4 somewhere right here. Or maybe you can, if you're doing this in a sheet of graph paper, you can just plot in just 2 coordinates and you just join the lines, because a linear function is always in the form of a line. So perhaps we're already done right here. You can just plot some more coordinates if you want more detail. So yeah, the graph should look a little bit like this. And don't forget to label the function that we're doing. In this case, I'm going to write the original function. We have 2x minus y minus 5 is equal to 1. And we have labeled our y-intercept. Now we're ready to label the x-intercept, which is where y equals 0. And fortunately, we have our y equals 0 in our table, which is when x equals 3. So our x-intercept is when x equals 3. So I'll just mark 2 right here. And keep in mind, my drawing isn't as accurate as probably in a sheet of paper, because I'm using Apple Notes for this. Okay, so we're done with part B. Part C is pretty easy. Find the gradient of the function. So if you know our point source formula, which is y equals mx plus b, m is the gradient, b is the y-intercept. So by suiting coefficients, we know that our gradient must be equal to 2. So this is our answer for part C. So for part D is pretty interesting. In the same plane, draw the line x equals 1. Then write down the coordinates of intersection of the 2 points. And keep in mind, the equation x equals 1 is a vertical line with an x-intercept of positive 1. So our graph should look like this. So it will intersect the x-axis at x equals 1. So something like this. I'll just erase a bit right here. So let's just label the function x equals 1. Alright, and we need to find the coordinates of intersection. And if you have a graph paper, you already probably will be pretty easy. However, in this case, it's very nice that we have our value of x equals 1 in our table right here. So when x equals 1, y is equal to negative 4. Or you can just plug in x equals 1 into the equation, because we need to maintain the equalities of both functions. So after doing either ways, we get there our y coordinate will be negative 4. So our coordinate of intersection will be 1 comma negative 4. And for the last part, label point A as a y-intercept of the function 2x minus y minus 5 equals 1. So the y-intercept. So I'll just erase some unimportant details for this question, for this part specifically. Okay. I might need to erase more of this. Okay. So we need to label point A as the y-intercept of the function. So we know our y-intercept is right here, is at 0, negative 6. The x-coordinate is 0 because it's on the y-axis, and anything on the y-axis has an x-coordinate of 0. And point B as the x-intercept. which is at this point right here. I'll just write the specific coordinates. So at point B at we have our x coordinate, which is 3, 0, 0 because it is on the the x-axis, sorry. And lastly, point O at 0, 0, or in other words, this is in the origin. There we go. And then we need to find the area of the triangle ABO. So I'll just shade the area right here. There we go. So remember our formula for the area of a triangle. Our area will be half of our breadth times height. So let's take our breadth of the distance between point O to point B. So point O has coordinates 0, 0, B has coordinates 3, 0, and you can just see the distance between point O and point B is just 3 units. It's pretty easy to see that. And for the distance between O and A, which we are going to call that as height, we have the distance. So coordinates of point O is 0, 0. This coordinates of point A is 0, -6. So that means the distance between point O and point A will be +6, and we need to maintain that in this case distance must be positive. So yeah, and then calculating this, we'll get our area will be 9 units squared. I'll just write the units right here. So our area for our triangle right here will be 9 units squared. So that's it for our first question. Let's get into the next one. Alright, for the second example, so I would say this is a pretty interesting one. So the total charge $C for a job which takes X hours to complete is given by the function C equals 60 plus 25X. So first we might want to state what the 60 and 25 might stand for. So we know that X is a variable and 60 is a constant. So what that means is probably 60 is like the fixed value. So it's probably like if you want to volunteer for a job, okay, so okay, for like the fixed charge you're given $60, something like that. And for the 25, the coefficient of X is probably the charge per hour. So if you work longer, you get more money, something like that. So yeah. So let's just write in our part A. 60 might mean the fixed charge, or yeah, something like that. Any terms that might be synonyms for this. So, and while 25 is the charge per hour, or I would say the increasing charge, or something like that. So for B, we need to complete the table, and this is pretty easy to do. If you know the function, you can just plug in some inputs. So for X equals 1, so we have 60 plus 25 times 1, and that will be equal to 85. And when X equals 2, it will be 60 plus 25 times 2, which will be 60 plus 50, which will be 110. And when C is equal to 160, this will be equal to 60 plus 25x. I've just formed a linear equation, and then you can just subtract 60 from both sides, and then dividing it by 25, you will get that X equals 4. So let's just fill that in. And For x equals 6, you can just plug in it once again. So we have 60 plus 25 times 6, which will be 60 plus 150, which will be 210. Alright, and for part C, draw the function in a given coordinate plane. We go for only the first quadrant because we don't like negative charge and negative time. And I should have added the x-axis. There we go. So keep in mind our y-intercept is at y equals 60, so it's somewhere right here. And we can just obtain that from the Poinsot formula and inserting coefficients. So let's just plot our points in the plane. So when x equals 1, c is equal 85, which is around right here. 85 is somewhere between this. X equals 2, c is equal to 110, somewhere right here. And then we have x equals 4, which is 160. So let's just draw some dots, dotted lines. And we have x equals 6, c equals 210, which is slightly above 200, somewhere right there. And then from this we can just connect the lines, connect the dots, sorry. So something like that. And I'll just fix this part probably. There we go. Okay, for part D and the last part, from the drawn graph, determine the charge if an employee takes 4 hours to complete the job. So straightforward, you can just substitute x equals 4 into the function. However, since we already have a drawn graph, we can just look at this. So let's look at x equals 4, and then let's draw a vertical line and stop where it intersects with the function. And then from this we need to draw a horizontal line to the c-axis to see where this value corresponds to. So in this case it's 160. So yeah. So for the part 1, our answer will be $160. And for part 2, we'll do the exact opposite. So the total time taken in the total charge for the employee is $185. So we're going to look at $185 first, which is somewhere around here, slightly above probably. And then we're going to draw a horizontal line, stops where it intersects with the function, and then draw a vertical line. And this value corresponds to x equals 5. So the total time taken for a total charge of $185 will be 5 hours. Alright, so this is it for example 2. Let's jump into the next example. Last example. So for the part A, we need to label some points. So P at -1, 1, so X at -1 right here, and Y at +1, so point P is right here. There we go. And then next point Q is -3, -1, so X at -3 and Y at -1. So it's right here. So this is point Q. And then we have R at 3, -1. So 3 right here, -1 right there. So it's somewhere right here. And perhaps if you want to draw this in a graph paper, it will be more accurate. Alright, so I just kind of like join the line to make a triangle because that will help us for the next few parts. Alright, So next we're going to find the gradients of the point lines. So we have P, Q, QR, and PR. So let's just write our VRI part. And perhaps we're going to rewrite our coordinates before. Q is at -3, -1. R is at 3, -1. There we go. And the formula for the gradient is y2 minus y1 over x2 minus x1. And you don't really need to worry about plugging in the wrong coordinates because you'll always end up with something like a negative over negative when it's supposed to be positive. So the negative and negative will cancel. So the only thing you need to consider is to don't mix up the x and y's. So for the first part, we need to look at points P and points Q. So let's say we're going to take this as our y2 first. So if y2 is 1 and our y1 is -1, so we have 1 minus -1. And then our x2 will be -1 and our x1 will be -3. So if -1 minus -3, the top one will be 2, the bottom will be also 2, leaving us with +1. And you can also check if you did the other way around. If you select Q to be the x2 and y2 coordinates, you'll also get the same answer. So for part 2, you don't actually need to calculate the coordinates because from this graph we know that QR is a straight line. I would say a horizontal line, and the gradient of a horizontal line is 0. Alright, for the third part, we need to consider the line PR. So let's say we want to plug in 1 as our y2 value. So we have y2 is 1, y1 is -1. And then x1 will be -1, x1 will be 3. So if -1 minus 3, the top will be 2, the negative will be -4, it will be -1/2. Alright, so that's it for part B. Part C, find the area of the figure enclosed by the lines PQ, QR, and PR. Then state the name of the shape. And if you notice that I said something about triangles, yes, PQR is indeed a triangle. And remember our formula for a triangle. So the area will be 1/2 times our breadth times height. So for our breadth, we're going to take line QR as our breadth. And good thing this is a horizontal line because it will be probably harder if it wasn't. So we are going to consider our x coordinates only. So the distance between -3 and 3. So we can just calculate this. So we have -3 minus 3 is -6. However, a distance cannot be negative, so we're going to put +6 as our breadth. So we have +6. And our height will be, I'll just draw some dotted lines. Right here, it will be this distance. So this is at x equals 1, and this point will be at x equals -1. The distance between these two y coordinates will be +2. And remember, we're going to only take the positive values. Alright, so after calculating this, we'll get our area will be 6 units squared. And you should have we could say that PQR is a triangle, something like that. Okay, so for D it's a pretty interesting one. We need to find the coordinates of S such that PQRS is a parallelogram. So we need to know like the properties of a parallelogram. It has two pairs of parallel lines. So what we can do is just draw two parallel lines. First parallel to PQ, so something like this. And what I mean by parallel, I mean the same gradient, so something like this. And you can just extend it way further. The more you extend, the better. And then next we're going to draw another parallel line, and this time parallel to QR. So yeah, and we need to label this point of intersection because this is where point S is supposed to be. And where is this point S? So notice our S lies at x equals positive 5 and y at 1. There we go. So we can just write our answer as at 5,1. And that finishes this example and this video. So hopefully you guys enjoyed this video. Please subscribe for more, and I'll see you guys in the next video. Goodbye.